Yes. Hi guys. Hi guys. Welcome. Welcome to the stream. Let me test here. Hold on, yeah. Lower this volume. All right. Okay, so before anything, I think I want to test the input shaper again. Let me just home all first the printer. Hey, Rene. Hey, Rene, come eat lunch. Yes, every time it's lunchtime for you. Yeah, good timing, huh? I want to do the input shaper first. Again, I want to do the input shaper again for this one, just to finalize, confirm. Because I think that time I didn't do input shaper for tool 3, tool 2, tool 2, yes, correct. So let me do the input shaper again. I need to open my CMD. SSH. What's the command? I forget the command. Oh, okay. That's the command there. All right. Global macro. Okay. The problem, Rene, I don't know how to pronounce your name. Rene Wilson. The problem why I didn't create a global macro for it is because this BTC Clipper macro is not done by me. It's done by Jack Beam. He is the master of Clipper on the software side. I don't know anything about Clipper. I mean, I'm not that very good in Clipper, so I can only depend on him to do the things for the software side, and that's the reason why it is at this stage of BTC as it is, because he's doing something else right now, so I don't think he have time to do anything. So I can only use BTC. BTC, I can only use what is available at the moment. I don't know how to do any mod to it, to the macros or anything. So whatever is available, I will be using it as long as it can work. So that is on my part, on my side. If anybody can do the macros, can tweak the macros, which make it more convenient, then it's a good thing. And maybe I can also share that in our Discord so that we can use that as well. So basically, whatever is available, that's what I'm using. So that's the reason. Hey. Okay, so now I'm going to do the input shaper. Let me open up this. Hold on, yeah. I'm going to open up my. Hey. Naughty. My cat go and push my camera. Hold on, yeah. Let me open up a window of orca. Where is there any orca window or not? Oh no. Orca. Orca slicer. Okay. So no chrome. Okay, I think it's not showing orca properly. Oh yeah. Okay. Hold on. Let me test again. Yeah. So orca window, it doesn't show the device properly. I think I don't use orca. Maybe I just capture my Chrome. Okay. So I open Linux Hive in Chrome. Yes. So the stealth changer, it uses macro to do the pickup draw off part. Yes, but this one is not stealth changer. This is Linux tool changer. Stealth changer, I think, uses the tool changer plugin software. This one is totally macros. There's no plugin for BTC. Is totally macros. There's no plugin. So why we opt to go with macros is because there's less tendency. This is what I know. Less tendency to break down if there's any klipper update or what. And I think a lot of people are more familiarized with macros, so it's easier for them to understand it. But like I mentioned, if somebody can do any tweaks to the BTC macros, is more better for the community, more better for us. Let me do the input shaper test first. Yeah. Test and calibrate, test resonant X. Okay. Once we finish the input shaper, and then we do the nozzle calibrate. What I'm going to use for nozzle calibrate is this camera. This is a simple cheap USB microscope camera from AliExpress, whereby I cut it into a shorter piece like this, and I make the base with a magnet for it so that I can put it on the bed and use the camera for nozzle offset X and Y. We will be using the Ember prototype software, but it's not the official software. It's a fork. I pin a rip-off of the software to use with other cameras. So that's what we're going to use. So right now we let it run its course with input shaper 2.0. We settle 2.0, then we will settle tool 1, and then tool 2. These three tools, once we settle them, the fourth tool, I don't have the wires for the umbilical. I haven't buy the wires. So I need to buy the wires for this, and I'm going to make one more tool head for 5. I mean 2. I'm going to put 6 total here. So I will need to make another 2 tool head and also the wires for them. But this one, as usual, we do the input shaper first. And then we will see how it goes. Why is my screen not turning on? My screen is not turning on. Something wrong. Maybe the connection. Okay. Let's do the Y. And connect to my WinSP. Hopefully after the nozzle offset calibration, we can do a test sprint. just a simple maybe a 3-color cube or benchy. See how it goes. I don't know. I have other PLA. I have to take my PLA. I got 1, 2, 3. I got 3, 4, 5, 6. I got 6 PLA colors to play around. Looks like not much different from the first one. Okay, so this one is done. Now let's move to T1. Okay, let's do a calibrate for T1. Zero, 0. Think don't waste time lah. Don't know whether we want to waste time with the input shaper. No need lah. We just do the nozzle offset calibration lah. Let's not waste time with the input shaper. Oh, I think we can do the tool. I don't know whether tool 3, have we done the input shaper for tool 3? Let me check. BTC tool 2, sorry. Tool 2 input shaper. Oh, in tool 2 input shaper also inside. I think we done the input shaper for tool 2 also. Okay, so after this we don't need to do the input shaper. I don't waste time. We just do the nozzle offset calibration. Okay, hold on. I need to swap over to the screen. Yes. And then we will open up Ember prototypes. Ember prototype. Open with Firefox. Ember prototype, this software, it doesn't work with Chrome. It only works with Firefox. Okay, hold on. Let it run. Open with Firefox. Open Ember prototype. Let me see. Why it doesn't want to open my camera? Okay, I think I must change the camera setting. Device manager. What is the camera name? The cameras, HD cameras, properties, details, driver ID. Where is the driver ID? Hardware ID, okay. 19028301. Oh, correct. HD camera. HD camera smalls. One 19028301. Looks like correct. Nope. Doesn't open with Chrome. Why is my camera not working? Oh man, what the heck, man? Let me turn back to this, yeah. Ah, come it doesn't want to turn on here. Let me try here. Cannot. Not. Maybe. That's okay. Need to update Firefox. Oh man, why you need to update now? Why it doesn't on camera? Use camera allowed. Are they allowed to use the camera? Is there a problem with my camera or what? Oh, don't know why the camera doesn't show up. What the heck? hardware ID 19028301. This is correct, right? One nine zero two eight three zero one. HD camera, correct? Oh man, let me try to add a camera. What's that? Video capture device. Yes. What's this? Boom. I think thumbs up. Camera's not working. Oh man. Asal not working eh? Why is the camera not working? Ayah. Camera not working, man. How about try to open with IE? Sikit. What is this? Not working. Okay. There's a problem with my camera. Ha 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 ha. So I think the nearest we can try to use is we can try to use tabi. The camera not working. I need to check. Just use tabi lah. Let me find my tabi probe. This one. Okay, guys. Camera is not working, so we're going to proceed with tabi. This tabi probe. Just my luck today. Tabi probe, the magnet might not be strong enough to produce a reliable result. Okay. Wait, I don't think I can put first. We will need to turn on the pin, tabi pin. You can't see what I see. Oh yeah, I know. The camera doesn't capture in my PC. I think the camera there's an error. Let me see BTC tabi. This one. PA0, travel speed 20, spread. Oh no, not this one. BTC, I think notch. Yeah. Notch is the one. Yeah, this is the one. I don't know if it can manage. The problem is it always get the timer to close error when using this BTC notch, the macro that Jack Beam did. We always get timer to close error. So we're going to try to see if we can manage to complete the calibration. All right. So PA0, we will test this. BTC variable, BTC notch. This one. Let's do a save and restart. Oh, must bring down the. Okay. Save and restart. Connect to the Pi. No, previously it was working. The camera when I plug in previous it was working. I think the wire I think there's a bit of a problem, as you can see here. The wire came off. I put hot glue to prevent the wire from coming out, but the wire become like that. So I think there's a problem with the wiring. I will check the wiring. So this one we are going to test tabi, but let's check tabi button first. Query button. Okay, we will query button. Notch sensor pin release, but when we press, is it press? Yes. Okay, it's working properly. So as usual, we will do home all first. Hopefully, can get through the entire routine of probing, because it always get timer to close. On my VZ board, it doesn't have the timer to close, but on this Linux Hive the first time I test, I get the timer to close. So it could be my wiring or the Pi. I'm not very sure. If doesn't work, next we can try is using the tool changer plugin nozzle macro. I don't know why my camera. I should have tested just now first before I start the stream. Okay, never mind. After this, we just do the tabi. Hopefully everything works. Okay, for tabi, what we're going to do is we will lift the Z higher. Let me use it on my phone. So we're gonna bring the Z, let's bring the Z30 first. Okay, let's try to put tabi below here and see whether does it clear. Okay, not clear. So I think it's 36, is it? Okay. Okay, let's move the tool head a bit. Give some light, can see, man. Yes, okay. From the side. Okay, let's move the tool head to the front a bit. Okay. From the left is okay. From the side is okay. From the front is okay. Let me bring down the Z a bit. Okay, now we need to. Okay. Okay. So let's lift it up by 3 mm. Okay, let's try to do. Hopefully everything goes well. So what we need to do is we will need to click nozzle notch fine tool offsets. Hopefully everything goes well. Nudge fine tool offset. If it gets timer too close, the dock slide will slam down, slam down. Zoop. All right. Nudge fine tool offset. Here we go. Okay, now it's hitting. Oh, sorry. Now it's hitting all the tool. Hitting up all the tools. Let me open up my camera back here so that you guys can see better. Okay, now it's doing tool 1. Just hoping that everything is good. Fingers crossed. Oh, just now I think there's a bit of a problem. It hit the tubby. It hit the tubby when it's probing the tubby from the back. So we will need to make sure the tubby move back more. Let's adjust that. But so far, looks like it managed to complete. Okay, just now is the problem. So you need to move back in Y more. We can adjust that. Okay, it's complete. Don't know whether you guys can see that. Let me show up my here. There. So the calibration offset are all completed, but the problem is just now. Wait, let me pick up my 2.0 first. That tubby movement, it hits the probe too early. So what we're going to do, we change nudge when you want to find it moves back here. Okay, locate sensor. Y minus 11 here, Y4. Okay, this Y4, I think we need to increase it to maybe Y6. Y6 and then Y minus 11 going to the front. Yes. Okay, let's try now. We will save first this. So that it moves more to the back. Okay, let's bring down the motors first. Oh, let's take out our tubby first. So let's do a motor off first, and then we will save the VTC nudge. This section down here just now, so we will need it to move back in Y more. So Y6 down here. Okay, let's home all. We have to redo everything back. we redo everything back, yeah. Just now it managed to complete the 3 tools without any timer to close. That's already a good sign. Okay, now we will do the quad entry. I think I should make one extension to tabi. If I want to do tabi, I just put it, mount it at the extrusion so it's firmly mounted so that it won't move. Yeah, I think I should do that. Just put one mount down here. Shoot, would that be okay? I will try it. I will try it. Don't worry. All right. Okay, code gantry done. So let's move back again. Sorry, I have to come in front. Code gantry done. Why is this fan not moving? Is it the temperature is low already? Check the temperature. What's the temperature? Oh yeah, so this is below already. That's why it's off. Okay, let's bring up the Z just now is 36. Okay, let's put our tabi back in the middle. In somewhere down here just now. Make sure that the wire doesn't make it move. Okay. So let's move the to the right. All right. Now we need to move it to the front. Can see from here. Let me see from here. To front. Yes. Okay. All right. Let's do another tabi calibration again. One more time. Notch fine tool offsets. Okay, so now it's hitting up everything. Let me check the fans. Fans all are on. Okay. Now it will heat up the tools to 150. It will calibrate nozzle tool 1 first to get the base. And then it will nozzle offset calibrate tool 1. Tool 1 just not tool 0. So tool 1 and then tool 2. Okay, we see how it goes, guys. The left and right is okay. Okay, now from the back seems okay, clear. Too much. I think 6 is too much. 5 is better. But we need to check the other tools as well. Okay, now you will pick up. Next is, all right, it will do tool 1. Let's see how it goes. Oh yeah, this tool head is a bit forward. Maybe by 1 mm forward. Oh yeah, it moved. Not enough. So we will need to increase it some more. Maybe just now 6. We add another 2 more. Okay, we need to add another 2 more. Let's change it. Not enough. Just now. VTC nudge Y. Let's put it 8. 8 here. And then it will move forward another 2. So we put here 13. Okay, we're gonna save here. Change back to 20. Let's take out our nudge. Take out our tabi. Okay. And let's save and restart again. Okay, make hopefully third time the charm. Hey Nadir, welcome. Nadir 3D, welcome. Okay, this is the third try. So let's home all as usual. See you, Ren. Thank you as always for tuning in. Dock and undock plus the lift speed. What do you mean? What did I adjust? Dock undock is still at 700. 700 speed. 700 at 7,000 acceleration, I think. But when it dropping off 400, the travel is 700. Dropping off is 400. Okay, let's do the quad gantry. Hopefully this time it managed to clear the tabi. I need to tune the tabi movement again, because I think the tool 1 and tool 2, the tool head is a bit 1 mm a bit forward. Okay, right now let me open up, you can see better. So right now we're doing quad gantry. After this, we will do the nozzle offset calibration using the tabi again. So that you know, this is the tabi that we created for nozzle offset. Much easier, similar to nudge, but a bit easier to build. Yeah. The dock undock is the dock undock speed. Let me open up here so that you can see. Hold on. My dock undock speed right now is 700 travel, 400 tool change. So 700, I think the acceleration is 7,000 if I'm not wrong. Acceleration follows the printer acceleration. Okay, now it has completed. Okay, so what I'm going to do now is I will move, hold on, not screen, camera. Okay, now I will need to put my tabi below here. Let me take my phone. All right. So first thing, we will lift the tool head up so that this tabi can go below it. Just now we did at 36. So let's put this tabi probe below it. Put it nicely so that it will move. Okay. Then we move the tool head a bit above, directly above. Okay. How about the front? Let's move it to the front. One more. Yes. Okay. Let's move it down a bit. Down. 2. And then 1, 2, 3, 4. So it will be at 38, I think. Maybe just 37. Okay. So let's do the nozzle offset calibration. Yeah. So we will do nozzle offset calibration, which will be at here. Nudge, fine tool offset. Okay, let's click it. So once we click it, all the temperature will goes up to 150 to do the calibration. So there are 3 tools down there. So it will do the first tool. Let's hope we don't get any timer to close. So when the temperature reach 150, the nozzle will start probing. Okay, now the first one, you will probe in Z, same as nudge. I think those of you who are familiar with nudge, it's the same as nudge. Oh, I put it at 8. It seems a bit too far, but I think it should be okay. Yeah, should be okay because later the tool is further up forward. See whether you guys can see that. I will show you. So now it's probing tool number 1, tool 1, T1. Okay, X. Yeah, much better. The distance is much better. Okay, now you proceed to T2. Yes, a dedicated location, but like if you have a floating tubby or floating nudge, it's much easier if there's no dedicated location. You just place the tubby below the nozzle and you press the macro button, find offset, then it will automatically save that location. So for if you have a fix, if your printer allows to have over travel to the left, to the right, or to the front, to the back, yes, you can put the tubby fix. It's much better. But for those who don't have over travel, free location, you don't have a fixed location, this will okay. So we go to the screen. Right now the tubby has done. Let me pick up my T0 back. Okay, so we will see the result down here. Let's see the result. Okay, first we will check tool 1. So tool 1 at the carriage, this one, tool 1 at carriage. So calculated offset is this one. So X minus 0.45, Y 1.93. So we go X minus 0.45. So X is minus 0.45. Y is 1.93. Let's save this first. Let's check again. Just now. T0, T1, no, this one. T1 at drop. T1 at carriage. Oh, this one. So Z is 0.25. So the Z offset is 0.25. 0.25. Okay. I think we don't set the Z first. After this, we will just calibrate the Z. Let's double calibrate, because since stubby is a rounded ball, the Z might not be accurate if the nozzle is not probing exactly at the center. So okay, X 0.2, Y 2.33. X is 0.2, Y is 2.33. 0.2, 2.33. Let's confirm it again. 0.2, Y is 2.33. Okay. Okay, so we already saved the X, we already saved the Y. So let's take out the tabi. So just now we can just save and restart here down here. Okay, now we're going to do tabi Z, right? So for tabi Z only, first we will turn off the notch, and then we turn on tabi Z. Let's save. Let's open tabi Z. Not this one, sorry. Tabi Z, okay. So tabi Z, okay, same thing as usual. So we just put there, and then you will do the location. Okay. So let's save and restart. Tabi Z. Okay, so now we will need to repeat the same thing. Let's do a home all, and then we will do a quad gantry, then we do tabi Z. Hopefully also we won't get timer to close with this. So Nadir, what project are you up to now? What project are you currently doing now? I know that you are doing the Nebula extruder, right? By Big 3 Tech. How's that going for you? Okay, hopefully after this tabi Z, everything will be okay. Then we can try to print. Let me take out some filament first. We got blue. We got black. We got blue. We got black. And then what do we have? Let's use the orange. Yes, I think let's use the orange. Blue, black, and orange. All these filament are all not dry filament, all are wet filament. So for PLA, blue, black, orange. We are waiting for the beta kits to arrive and test. Woo! All right, man. That's good news, man. Exciting. And how is your place now? Everything set up properly already? Your new studio? All unpacked, all done? Okay, guys. So now, as usual, we will need to leave the... Just now was at 37. Okay. Let's put it down here. Just now. Same thing. Okay. 1, 2. Okay. Let's check from the side. 1, 2, 3. I think this is much better. Okay, so now let's do a notch fine tool offset again. Okay, so this will be nudge, fine tool, offset, but only do calibration of Z, if I'm not wrong. Oh no. Oh, tabi. Okay, tabi, fine tool, offset. Okay, this one. So this will be Z only. Yeah. Let's try. Hopefully it goes. The new studio is not ready. Lots of things to do. I need to solve it. Yeah, man. Exactly. A lot of things to set up a new studio. I know. I understand that. Even this room right now, which I'm using, oh, I to slowly have to put everything in. Okay. Okay, looks like it's done. Let's try to see. Just now, where is it? Okay. Don't know whether I did it correctly. So T1 at carriage, tool offset Z0. T2 at carriage, tool offset Z also 0. Huh? Oh, okay, so it's wrong. Wait, let me check. Tabi Z, tabi find tool offsets. Yes. Oh, this one move delay 1. Resolution 0, traverse speed 30. Okay, hold on. Let me check the just now nudge what they put. 0.05, then traverse speed 30. Okay. 0.05, traverse speed 30, correct? Move delay 1. Okay. Why does it move the Z so high up? Where does the Z change the Z lift? Oh, here, Z minus 4, locate sensor. Z minus 4 and then Z4. It should be okay, right? Oh, maybe I should bring it higher. Okay. Sorry, wrong. Okay, never mind. We will try again. Let's change to T0. Just now it parked at 175 by 179, 178. Okay. Let's move it 1. Two. 1, 2. Okay. But this time we will move it higher. Let's move it at 38. 38, maybe 39. Okay, now at 39, we will see how it is. Let's try again. Tabi, fine tool offsets. Every tool has an eddy current or only one? No, actually, I'm not using eddy current. But if you are using a probe, you only need one probe. You only need one probe for tool 0. The rest of the tool, you don't need any probe. Because only tool 0 will do all the Z, your Z homing or your Z chord gantry, everything is only with tool 0 only. The rest of the tool don't do anything. So only tool 0 needs the probe. You can use eddy. We have the mount for eddy. We have the mount for eddy. We have the mount for beacon. We have the mount for cartographer, and also we have the mount for clicky. So you only need one probe only. Yeah, yes, correct. So you only need one probe. I think we need to lift this a bit higher some more. So let's leave it a bit higher. What's the, hold on, let me get back my 20. Maybe we leave it at 40. Yeah, it's too close. Just now was 175x, 178 in Y. And then we need to move front 2 and move right 2. Okay, and then let's move it to 40Z. Okay, let's try the nozzle nudge again. Not nudge, sorry, tabi. Tabi, nozzle, nudge, tabi, fine tool offsets. Hi, Android Umair, thank you. Custom printer, what custom printer do you have? We can always, yes, see ya, Nadir. Thanks for tuning in also. How, I mean, have you installed Linux already or not, or at your printer? Have you installed Linux on your printer? If you have installed Linux on your printer already, then we can do a lot of things with it. How to get it working, we can do it. Hold on, let me settle this nozzle offset calibration. Last one is the Z. All right. Okay. Now let's try to find the first T1 at carriage. Oh no, T1 at carriage is this T0 at carriage, T1 at carriage here. Okay, so tool offset Z 1.2. So T1 Z offset is 1.2. Let's save it. T2 tool offset is 2.15. So T2 tool offset Z is 2.15. Yes, okay, so we have completed everything. Hopefully everything works okay. Now we can plug out our tabi. Let's change back to tool 0. Turn the motor off. And let's save and restart. Oh, the 100. Okay, that's the 3D printed printer, right? Extended, that means you extend the size, okay. Or is it extended in Y or extended in X? You have got all the parts now for Linux stuff. Started out with Darks, but changed my course midway as I find your design. Oh, okay, thank you, man. I mean, yeah, I started with Darks as well. Don't know whether you notice, I was in Darks too before that. Previously, I was in Darks as well. Okay. If you really, if you need any help with your design or carriage or anything, do PM me inside, or not PM, just post, tag me in Discord. Yeah, I will try my best to help you. Anything regarding the design, I got no problem. But software wise, I'm not so champion, so we will do what is available. But right now, okay, now we have already done that. Now let's home all first. Okay, let's change back to the bigger screen. Okay. Now let's heat up. Let's bring let's bring the tool. I normally bring the tool up maybe to Z50 when I want to do a filament chain, because later I need to extrude some of the filaments. So we will heat up the heater to 240 because it's ABS inside here. So after this, we can get to printing. Woohoo! We will test the print. Woohoo! I think ours is also a bit easier because thanks to Fizek who supply a ready-made bomb kit for us, so that it's easily if you need the kit, you can buy from Fizek instead of self-sourcing. So it's much more easier. Everything is wired, LED is wired, micro switch is wired. So it make things very, very easy. Okay, we will do a slow extrude first. And after that, we will do a hard retract. Okay. So normally what I did is during retracting, I will pull from here. If not, it will leave a bit of a like a fine hair, you know. So I don't want that. So let's pull off this first. The filament, black filament is off. Let me cut. Okay, let's keep our back filament. Let's put in this orange filament. This orange filament is wet. It's old filament. I haven't got much time to test to print stuff, you know, because there's a lot of testing to do with Linux that I barely have enough time. With the temperature, I need to bring down to maybe 200. Let's change to 200 temp. Okay, so we will load the filament. Okay, let's extrude. Okay, now it's extruding filament. Not enough. Extrude some more. Why does it doesn't want to extrude? Or is it the temperature is too low? Is the temperature too low or what? Let's bring up the temperature again. Let's try to pull out again the filament. Is the filament stuck somewhere? I'll check the filament again. Filament, maybe just now because there's a balance ABS inside. My mistake. I should have also set to 240 and then after that I will reduce to 200. What? Stupid. My mistake. My mistake. Oops. Filament come out. Okay, let's try to extrude again. Tighten up the extruder a bit. Okay, it's coming out. Let's extrude again.
Dengan premium. Mulai dengar bareng bersama teman dan tunjukkan lagu favoritmu kepada mereka tanpa jeda iklan. Dengan fitur ulangi dan lewati tanpa batas,
Thank you, man. I didn't know that you noticed me from dark as well. I actually, it's been a long time since I've been inside ducks. Uh, oh, okay. So BT Lucas also did the 100. Okay. BT Lucas also, if I'm not wrong, previously has a VZ board, if I'm not wrong. He also did the ducks. I was with him. He did ducks first before me. He is a few steps faster than me. So three-way mod for Z actually uses ended three blade. Okay. I got it. Now I know. Got it. So I think initially for you, in your case, what you need to do is you will need to change the carriage because the 100 uses linear rod carriage, right? So you will need to change the carriage. Previously I did want to try to do linear rod carriage previously. I think it's so very easy. It's very, very easy for the 100 carriage. Very, very easy. I don't know whether does he provide the step file for the 100? If he provide the step file, then it's much easier. Should be very, very easy to adjust. Okay, now let's go to T1 and then we will now load the filament for T1. Let's bring T1 temperature 200. Okay. Let's load the black. We got black filament here. We're going to use for T1. So this is the black. This is the orange is Sunlu filament. The black is Elegoo filament. So let's load the black filament. This one, this T0 umbilical always gets stuck down there. This one I forget to trim. I think I must trim this. Because this one every time gets stuck down here. Okay, this hole is too small. Let's try to drill it a bit. Hold on, I think the hole is a bit too small. Oh, yeah. Let's just drill the hole a bit. This thing down here. Hold on. Let's do a quick drilling. Hopefully everything is okay. Let's drill from the top later. Okay. Just a quick drill. Fast game. So that thing can go in fast. We want fast. Okay. 200. Let's try to extrude. Let's see how it is. Extrude again. Okay, black is out, correct. Okay. This one, I never do any calibration of the hot end yet. Just leave it as is. We will use whatever it is as is just to get to printing. Then once we started to print, we can calibrate the hot end later. Just need to get it to test print. So now I have turned off this one. Let's pick up T2. Now let's heat up T2. Let's put in the filament. Okay, for T2 filament is down here. We will use blue, yeah. So we have orange, black, and blue. Oh, this one should be this way. Oh, yes. This one doesn't seem to be nicely placed. Okay. Okay, T2 temperature 200. Let's extrude. This one the TFV feeder not putting properly. Okay. Wait, I think there's some purple filament in the hot end. I think that is ABS. Let's change it to 240 temperature. If not, it will get stuck again. Okay, let's try to extrude again. Ah, yes. Okay, this time it's coming up. All right. That's great, great, great. Okay. Let's turn off the heater. You have the step file. Okay. You are using original carriage by adapting to the back mount plate to the Voron printed carriage. Wait, so you want to use the original carriage of the T100. So you want to adapt it to the back mount plate to the Voron printed carriage. You can do that also, but you can just make a new carriage for it, make a new plate for it, but the original back plate for the tool head is still the same, but for the carriage A, so that carriage A part is what you need, the carrier and lock plate. If you don't mind, you can share the step file with me in Discord, and I will be more than glad to try to create a carriage for you. Shouldn't be a problem. Should be very easy. Because previously someone also did mention want to use this linear rod. I think it's T100. I think if I'm not wrong, so it's T100. Or is it the bigger version of T100? I'm not very sure. But someone did mention, and I wanted to create it, but after that, there's no news about it, so I didn't do it. But if you can share with me the step file, yeah, I don't mind to do the carriage for you. So let's move back to T0 here. Okay, so right now everything is okay. I think I need to do the PID tuning because the extruder 2 just now, the temperature is not running very nicely. Let's do a PID for T1 and T2. PID, let's check klipper. PID tuning klipper. Klipper, heater, extruder. Okay. This one. So extruder 1, target 200. Okay, so let's calibrate heater 1 now, yeah. Just to confirm the PID. Okay. Oh, sorry. Let me move it to a much bigger screen, okay? Yeah, do share, Uma. I will be more than glad to do the carriage for you, don't worry. It should be very easy. Previously, I did have a look at one of the, I can't recall what printer, but it was using a linear rod as well, and I don't find it so difficult to adapt to Linux, so no problem. Now what we need to do is we will need to open orca slicer. So for orca slicer, what I will do is I will open up orca slicer. Hold on, yeah. Window capture, add existing orca. Okay, okay. Once we open orca, let's go ahead and open our test file. Voron cube tool changer. Let's do the okay, no, before that, normally what I like to do is I like to do this linear Z offset first layer tool first. Hold on, yeah. Okay. Let me open up the screen much more better. Hold on, yeah. Yes. Okay. Let's move. Yeah, much better. So that you guys can see what I'm doing. So we have 3. First is orange. Let's just put simple orange color down here. This is Sunlu PLA. Sunlu PLA for Revo Voron, correct? So then next we have black. This is Elegoo PLA V6. What is the second hot end? Clone. V6 clone. Second hot end is V6 clone. So I just put Elegoo PLA. Now third is blue, correct? This is using Sailfish. No, V6 CHP. Elegoo V6 CHP. This one. Okay. So let's change the color. This will be 1, this will be 2, this will be 3, this will be 2, this will be 1. Here we change to blue here. Let's change to orange here. Here will be black. Here will be blue. Here will be black. Yeah, okay. I think this is okay there. Top black, down blue, top blue, down black. Alright, okay. What's the height of this? 0.2. No, we need to make it into 2 layers. 0.4. Let's make it 2 layers, much more better. Okay. Linux Hive 2.4, initial purge, extruder 1, we got 1 Z hop, 2 Z hop, okay, all correct. And then here we should put PLA Voron speed, okay. Looks like there's a prime tower down here. Yeah, I might just put the prime tower. Slice the plate, please. Okay, the plate has been sliced. Let's upload it. Okay. Now we have done the PID. Okay, let's see. KP 42.993. Tool 1. KP 42.993. KP 42.993. KI 5.308. KI is 5.308. KD is 87.064. 87.064. 87.064. Okay, PID for T1 is done. Let's go ahead and move to T2. This will be extruded to target 200, correct? Okay, now we are doing PID for extruder 2. After this, we will print this, yeah. Very fast one, 7 minutes. Just to test print. Normally, why I print this is because I want to see how the Z layers offset between them. Because when you print this very thin layer, you can see the Z offset between the tools, whether it's good or not. Then after that, you can also see the XY offset also a bit from here. And then after this, we will try to print the Voron cube. Now we are doing the PID. Where's the PID? Where is my orca screen in my PC screen? Screen here. So here orca I turn off. So we do the PID first. And one more thing, when you are doing PID or you're doing input shaper, don't save, or you're doing probe offset, don't save and restart. We will put them in their each individual tools down here. So don't save and restart, guys. Let me check Discord. What's happening in Discord? carriage linear stealth. 6 mm spaces. What are the 6 mm spaces for?
Putar musik di momen yang tepat. Saat ingin memeriahkan pesta atau bersantai di malam hari, pilih musik
Yeah, this Trident is very nice, man.
iklan atau download untuk didengarkan offline di Spotify Premium. Ketuk banner untuk mempelajari selengkapnya. Temukan cara baru mendengarkan musik dengan Spotify Premium. Shuffle pintar akan menambahkan
Nice
rekomendasi
and clean.
playlistmu dan memberikan nuansa musik baru. Kamu juga bisa membuat sesi dengar bareng agar kamu dan temanmu bisa menambahkan lagu dan mendengarkannya bersama. Ketuk banner untuk mempelajari selengkapnya.
Planning where to mount the dogs is very important.
Berasa jadi lebih semangat aja gitu ngejalanin hari.
In how your flow, how your flow, how your preparation flow. Still haven't PID, so slow. Do. The variation is so high. This one V6. This is the V6 CHP. The variation is very high. Just now you can see here the Revo hot end very fast. Not the variation is not high. Okay, PID is done. KP 21.648. KP 21.648. Now for KI 1.046. 1.046. Now for KD 112.030. 112.030. So we're going to save that. Okay, our PID is done. We can start to print. So let's take T1 first. And then let's do the... I think let's wipe first. Let's wipe a bit. Let's wipe the bed a bit. Okay. Let's save and restart. let's do a home all. Oh yeah, okay. For printing, for printing, you will need to add this tool changer printer. Here there's a, if you look at add printer, there's a tool changer printer down there. Wait, let me do a code gantry level first. So hold on. Let me bring back my orca screen. So what you need to do is you will need to add this tool changer printer. Select remove printer. Then once you have the tool changer printer, the most important thing is inside your machine G code is the print start. This is, I think is, I'm not sure now what's the stock print start G code, but this print start G code, you can leave it be. You just need to adjust how it's going to do the purging if you want to purge the prime. Actually, not prime, it's purge. So it will do, I set it to purge line, you know, a few lines like how the Prusa Excel do. So you just edit the location over here, the coordinates. You just need to edit according to your printer. So this is the number one, very important. Number two, only for flying gantries. Okay, only for flying gantries with dock slide. So only for flying gantries with dock slide, what you need to do is you will need to add a layer change G code. This one, BTC layer change. So you will need to add this inside your layer change G code. BTC layer change. This is very important as well because it will keeps your dock slide following the gantry height every layer. So whenever there's a layer change, your dock slide will follow. So that will ensure that the dock slide will always follow the gantry height. So this must be inside your layer change G code as well. And then for your printer itself, hold on, let me change back to the printer. For your printer itself, you will need to what just now? Oh, okay, print start. So your print start, where's my start? Okay, this one. So you will need to have this inside your print start. This will tell the printer of, this will read from the slicer, works with the slicer to read the slicers tool in use, what tool is used in the slicer. So this is very important as well up to here. Okay. So this is very important, your print start as well. Your print end, you can do whatever print end you want, but for me, I will always ensure that it will pick up T0 when it print end. This is it here, T0. And this is to turn off all the extruders. As you can see, turn off all the extruders. Move to the back, save Z, save Y, move to the back, all the normal stuff. And then I pick up T0. Before everything, it will pick up T0. Okay. And I also have the Julian's Chill LED, Clipper LED plugin for my umbilical hub. I don't know. Hold on. I don't know whether you all can see or not here. Hold on. Let me try to zoom camera. There's the light there at the back. At the umbilical hub, there's a lighting. So that light, by using the plugin for LED, I use it to do the print progress, like print progress. So later I will show. Hold on. So later I will print with the LED print progress so that you guys can see. This way better. Hold on. Yeah. So this way better. Okay. So now we're going to do a test print. We already do everything, right? We already save everything. Wait, is it being uploaded already? Okay, the file is being uploaded already, so no problem. So right now, we're going to do a test print. Okay, the files is uploaded down here. We have do, okay. So now, let's do a print test. Hopefully everything works. Fingers crossed. Did I set it up for PLA? Correct. Everything correct. PLA. Okay. Everything correct. Fingers crossed. I forget to test whether the part fan is working or not. Never mind. Just see. Okay, after this complete, we can call it a day, guys. Should be just in time. Think I move it back a bit. Yes. I don't know about the Z offset as well, so we'll need to change later if the Z offset is not good. This one we just based on our eye. Just eyeball it and then we can see. Guys. Hopefully, guys. Fingers crossed. Can see not? Okay.
Hilangkan kebisingan dan tetap fokus dengan suara berkualitas tinggi. Mau denger beat santai?
And then I also have the
Kaya, setiap
cam, klipper, adaptive bed mesh.
bisa batal kapan aja. Fokus lebih baik dengan suara berkualitas tinggi. Ketuk banner buat info lebih lanjut.
Rasain setiap beat, setiap lirik tanpa iklan. Dapatkan 3 bulan Spotify Premium standar cuma 70.
The last stream, this LED not working, nozzle LED already fixed already.
Tanpa gangguan.
And also the
Bikin keren.
carry sense switch not working also has been fixed. This tool 0 LED nozzle LED not working properly, showing orange color instead of white. I think the wiring problem. Maybe I will change it. I also needs to fix that because I need to reprint this cowl. This cowl is actually broken off. It's still working. Although it's broken off, it's still working because there's a magnet there. There's one thing I like about Linux is no matter how, it still can work. It's built to last. Okay. I don't know which tool it will purge first. Just stand by the... Okay, now it's purging this tool first. I think later it will change tool and don't know which next tool it will pick up. Okay, now it's purging the other tool, the black tool or blue. Tool 2 blue, okay. Oh, it missed the draw off just now. Don't know how come I missed the drop off. Okay, you see? It missed the drop off. Let's try to do a tool drop off again. BTC tool drop off, tool number 2. Oh, cannot. It doesn't want to draw off tool 2. Okay, so there's a pickup error with tool 2. We have to try to fix. Don't know what's the error. Let's clean up all the filament first. Let's deploy the dock slide. Here we will cancel first. Let's move the dock slide down. Let's move the tool back. There's something just now not properly. Let's try to pick up T0. I think cannot do because just now you already missed the step already. Sorry, yeah. Okay. Let's do a firmware restart first. You see, this is the problem, man. That's why you need to do the bashing properly so that you don't have this kind of problem. Just now it draw off. The draw off, there's a problem. Hey man, hey, wait to do. Hey, yeah. One thing good is you can learn a lot from here. I mean this. Okay, we already did a firmware restart. Let's try to do a homing again. Okay. Let's do the quad gantry. Why did it fail to pick up just now? Seems like what is the problem down there? Could be the pickup drop off location not properly tuned. We will try to double check again. Let me see what is T2. What is T2? Let me check. So T2 pickup 179 to 190. 179 to 190. Then 190 to 180. Okay. Pickup 179 to 190. No. Because of the coordinate. Motor is not skipping. Motor, I mean the yesterday I did a bashing, but I haven't do 100 bash because I want to make it quick. I do a very fast bash. just I think about 20 bashes. And then yesterday I did take out the T2 cowling, everything, because to fix the LED and the micro switch. Okay, let's draw off T0 first. So just now 179 to 190, right? Let's double check again. 179 to 190, correct. Okay. So let's move X to 179. So after that, I need to move in front, sorry. Let's open this. Now let's deploy the dog. Dog slide deploy. Okay, 179 to pick up 179, and then it will go to -1. Correct? Then 190. Okay, so far so good. Everything okay. Let's move back 50. And then let's move back front 50. Okay, here. I need the light. Okay. Let's move 10 to the left. Seems okay. Okay, so I think we don't move 10 to the left. I think we just need to move 181. Move 1 to the right. Here. So 181. Yes, 181. Okay. So draw off will be 190 to 181. That's the problem, I think. Woo! Let's try. Let's pick up T0 back. Okay. T2 is 181 here. All right. Let's do a motor off. Save and restart. Okay, hopefully now it's okay. Okay, we will do the print immediately. Directly do the print. Don't waste time. Okay, where is my camera? Here. So from the side here is the filament. I will show you the filament from the side. And this is the printer from the front. Okay. We see how it go this time. Woo! After this, we will stop the stream. At least it need to print. At least.
Putar musik di momen yang tepat. Saat ingin memeriahkan pesta atau bersantai di malam hari, pilih musik yang pas lalu dengarkan tanpa iklan.
At least give it painting, man.
Didengarkan offline di Spotify Premium. Ketuk banner untuk mempelajari selengkapnya.
Ah,
Oh my god, gak ada sinyal guys. Oh aman aja guys, karena aku bisa dengar lagu tanpa koneksi internet dengan offline backupnya Spotify Premium.
fingers crossed.
Gak perlu di-download, udah bisa kita play bahkan.
Yeah, the LED status. It's nice actually. This is Yoku idea, like I mentioned, it's Yoku idea. Lucky give the idea to. If not, it's just plain doing nothing down there. So might as well add the LED down there. Very nice down there, on top at the back. So I put that as print status as well, so that you can. I mean, if you have a camera installed, you can also at least see the print status, or I mean from far, so you can see. This is Voron tab, not touch probe. Voron tab. The 5Z CNC tab. It comes with the kit. This 5Z CNC tab comes with this Voron 2.4 as well. So I'm using the tab instead. Hopefully this time we can get to printing. Come on, come on. Fingers crossed, fingers crossed. No, there's no there's no eddy probe or beacon probe. Is Voron tab. You know the Voron tab. This one is Voron tab, not eddy tab or Kato tab or beacon tab. No, it's a Voron tab. I think after finish I will show you how it works. Oh, looks like it's under extruding. I think just now because of the temperature. It's under extruding and this. The filament doesn't seem to want to come out. So there's a problem here. Let's see for this one. This one is a bit too high. So the Z must be lower just a little bit more, I think. We will see if we drop off. Just now the drop off also a bit not so good. Now we see this black. So you will print black first. Because the Voron tab is the carriage itself is Voron tab. So that's why when the tool is on the carriage, you can activate the tab. If you have a look at the GitHub, our GitHub, if you have a look at the carriage section, under the CAD or STL carriage section, you can see how it's mounted to the current Voron tab. The carriage, how it's mounted to the Voron tab. So that's how it works. So there's no eddy probe. No complication. Yeah, correct, actually. I mean, if you are familiar with setting up eddy, then it's not a complication. It's quite easy, actually. Like for you, you have experience with eddy, you should have no problem with eddy. But for me, I'm not very sure. I haven't even get to try eddy also. I've been trying to contact Big Tech, but I don't know who to contact. So maybe one day I just buy eddy on my own. But since this is using Voron, I think I might use eddy on this VisiBoard. The next I will do after this is Linux Sling. Linux Sling use clicky because there's a servo clicky there. So Linux Sling uses clicky. There is the print progress. I don't know whether you can see that print progress. This one not coming out. This orange. Oh yeah, it's coming out now. Okay, good. The black seems to be a bit higher, so I think we will need to put it lower. There, you see? What is this? I think it's too high. The Z is too high. Let me try to lower the Z a bit. Okay, I see the problem. It is not pulling the filament. Let me try to adjust the filament grip. Everything seems to be a bit high. Just want to see this. Oh, okay, this one is too low. Z is too low for orange, for tool 1. Never mind, I just let it print first. Let me try to adjust this Z for orange. Yeah, I think much better. So +1 for tool 1. It's too low. Plus 0.1 for tool 1. Let's see how about tool 2. Yeah. Tool 2 also a bit too high. So tool 2 will be lower by 0.1 as well. I will show you what's going on the screen. Let me zoom in. Yeah, Nomi, I mean I all this it's not that I don't want to put. Number one, I don't think I want to spend on Nomi first because I have some other things to do. Like I need to add more tool head for my Linux link, for my VisiBoard. So I better spend the money on those. Number one. Number two is Nomi is maybe adding more weight, but just the aesthetic wise only is nice, look nice, everything. So it's only more for aesthetic. Number three is software wise also you need to do a lot of things on the software wise also. So I'm not very sure whether I want to try Nomi as well. So we see how. I mean, if Big 3 Tech offers to, I think I need to cancel this print now. All the print are coming off already. Okay. I cancel the print because the all the things are coming off already. So tomorrow I will adjust the Z offset again. The XY offsets, I will do the Voron cube calibration to further fine tune. So I need to increase the offset for orange. I need to decrease the Z offset for blue and black. Okay, so I think that will fix it. So right now, what we need to do is let's change it back to T. I see any problem? Okay. Now we can drop copy. So turn off the part fan. Okay, so I think yes, that will be it for the stream. Yeah, just fine adjustment, correct. Just the Z offset, and then once I print the cube, I can fine tune further for the XY. If I see a need to adjust the XY, I will adjust the XY. And then after that, I think it should be okay. Yeah, correct. I calibrate. Just now I did if after the stream, you can take a look at the video again. Just now I did the full calibration with Tabi. And I didn't get any timer to close. Thank God, man. So that means I think it could be due to the wiring because I changed all the wires, especially the power wires to the Pi. I changed them to a bigger wire and now it's getting more power. So I think one of the reason might be that or I don't know what, but just now I did the full calibration of the 3 tools with Tabi and I didn't get the timer to close. So that's a good thing just now. That's one of the one of the happy moments or one of the happy point of the day. Dog slide insane speed. I think it's only at the speed of dog slide is only at 400, I think. No. I have the dog slide faster, 600. This LDO motor works very, very good. This motor was recommended by Jason because I messaged him. I asked him a better motor and he introduced this motor, so it works very, very good. yeah, you will see, and then you try to see the video again, because the tabi really works very well. And what I did was I do the full tabi first, and then after I did the full tabi, I got the XY offset. I get the XY offset for both tools, T1 and T2. So I insert that offset. And then after I insert only the XY offset for T1 and T2, I did another tabi, but this time only Z. Because this time the nozzle will be exactly same position as T0. So that is the best way, I think. So I will do tabi, full tabi, and then tabi Z only, the final one. So that will be the Z offset. So that is the best way. So you can take a look. Just now I did. It's working very good. I just fine tune the movement a bit. That's all. Wait, my dog slide speed. Let me show you my dog slide speed. Dog slide travel speed 400 only at 5,000 acceleration. So it's not that fast. You know that dog slide you can bash also. you can bash dog slide up and down, up and down. Where is the bash dog slide? This. So if you bash dog slide here, you can bash dog slide up and down, up and down. So let me see whether I can bash this dog slide. Try to see. There. So you can bash the dog slide up, down, up, down. So this is to test the motor, test the once you do the bashing, then you try to do a tool change, make sure that it is consistent, not skipping any steps. So so this is a very, very good test for you. 400 is fast, yeah. It's considered okay lah. For me, it's okay. I wish it was more faster. Okay, so now we have finished the dog test. Now let's try to do a tool change again. So it has to be consistently able to do a tool change. Let's see. Okay. All right. So everything is okay now. Part fan is still on. I already turned off the part fan. All right. So I think that's it for today. Tomorrow I will just fine tune the Z offset, and then print a what? And then I will print the calibration cube, and then we see how everything is. All right, thank you everybody for tuning in. Thank you, Way to Do, for sticking me right to the end, man. Way to Do. I know you entered late, but doesn't matter. At least we managed to do a little bit of printing. But the problem is with the Z offset. I don't want to waste any time. It's 12:40 here now. 12:40 p.m. It's almost midnight. It's almost 1 a.m. here. So I will end the stream here, and then we catch up in another stream, whereby we try to print something. Oh yeah, sorry, I forget. I want to show you the what? I want to show you the Voron tab. Okay. So okay, wait. Never mind. I will bring up this. So if you see here, so this is the CNC carrier and lock plate, right? CNC carrier and lock plate. Alamak, sorry. Let me open the screen bigger for you. Okay. Okay, so this is the CNC carrier and lock plate. Let me zoom in. Hold on. Camera zoom. Okay. So this is the CNC carrier and lock plate. As you can see, And at the back here is the original Voron tab. So what I had to do, I mean not what I had to do lah. What I did is, this is Voron tab back plate. So I just removed this back plate because our CNC carrier is the same mounting hole as this part of the Voron tab. So I removed that and adapt the rest of the Voron tab part to our CNC carrier. You can see here. So this is tab itself. So this is Voron tab. Oh, this thing come out. So you can see the light change from here. If you lift up, the light change to blue, that it activate the Voron tab. So when you put the tool head down here, so when I don't know, it's hot, not hot. So when it hit the bed, it will just push up. So this is how it works. So Voron tab. But also I'm using our CNC carrier. You can use the printed carrier and lock plate as well. This is because I did the CNC parts. I think for your twist lock, you should try the CNC. Try to CNC, brother. Go for it. I really support it. Very good. Worth it. So that is how the thing works. So it's not, it don't have eddy or beacon. But I want to try also. I want to try eddy. I want to try beacon to see how it goes, cartographer or something like that. Because I haven't tried it with any of them, but I want to give it a try. Okay, for the cables. Okay, good. That's a good point. Okay, hold on. So for the cables, I have to show you here. Hold on. Let me zoom in first. Let me bring it here. Okay. You can see that there's no cable on the carriage itself, right? No umbilical. There's no umbilical on the carriage. So where are the cables? So the cables are actually connected to these three bushing. Here one, here one, here one. All these four bushing, I have made them so that you can connect them to a wire each. Although they are CNC, but you are connect them to a wire each. So for beacon and eddy, they have 4 pins. Beacon and eddy, if using 4 pins, if I recall correctly, they are using 4 pins. So these 4 bushing, they have wires connected. So you can connect them via wires from here to how you want to mount them on your carriage. And for our back plate, these 3, 1, 2, 3, these 3 dome nut also, there is wires there. Wait, let me take this. Let me take this tool head. So, if you take a look here, there's a hole there. There's a hole there. All these four dome nut, there are holes at each one of them, whereby you can slot in wires. So each dome nut are connected by wires connected to the EBB port. So this dome nut can connect to the carrier and lock plate bushing. So once they are connected to the bushing, they will activate your eddy on the carriage. So you can actually install your eddy on the carriage, and then you can activate them by using these 4 bushing and 4 dome nuts. So that is how it works. So for beacon and eddy, if there are 4 pins, you can use the 4 dome nuts. So from here, you can use the 4 dome nuts for the 4 pins, connect them to your EBB, how they are wired to your EBB, which port I'm not very sure. And then these 4 dome nuts, if you have your eddy or your beacon on the carriage, you wire the 4 bushing to that beacon or eddy as well. So it's the same. So when your tool head is connected to the carriage, then it will get power up. As you can see here, let me show you from the side. Hold on. I show you from the side. Okay, you can see that there's a red light there, right? You can see that there's a red light down there. When I leave it up, there's a blue light. Let me turn off the printer light so that you can see. Hold on, Set case light LED off. Okay. So you, yeah, correct. It's just like the fan. Correct. But instead of the button head, I'm using the dome nut for the power. So it's the same way. So you can see here, it connected. There's a red light. So when I leave it up, it's blue. So this is activating the tap, Voron tap. So this is engaged, like press, release, press, right? So if I take out this carriage, you can see that there's no power to the Voron tap because the power comes from the tool head itself there. So the power comes from these three dome nuts. So if this tool head is not connected to the carriage, the tap doesn't work. So it only works when the tool head is on the carriage. So you can connect it. Yeah, so that's how it works actually. So that's why I decided to put it up for. That's why I decided to put it up for the 4 dome nuts. So let's say you have clicky. Clicky use 2 only. So you can put clicky on the carriage itself so that you can use the tool head to engage to the carriage to activate the clicky. So you don't have to have the clicky on the tool head itself. Yes, correct. When tap activate, it gets to blue. Skin Patil, is your docking mechanism, are you using kinematic coupling? Oh yeah, it's a kinematic coupling, correct. So it's done via magnets actually. We are using magnets. I don't know why some people say magnets are very slow. Magnets have their weakness. I'm not very sure why they say that, because they haven't tested themselves. But we have one user in our Discord who's running Linux at Voron speed, at Voron all-wheel drive stock speed. So we have user by the name of Gadi. He's running Linux on VisiBoard at Voron all-wheel drive stock speed. So it's not a matter of the printer cannot run fast, the tool changer cannot run fast. Mine doesn't run fast because I have done a speed test and it skips steps above 7,000. So it can't run fast. So there's no point. So mine doesn't run that fast. But Gadi, he ran his, I think, at Voron stock speed. I asked him. So it's not a problem. But yeah, we use kinematic coupling. So this is the kinematic coupling. I think just now you see it already. So this is how it works. So it will move here, disengage. So this is the kinematic coupling. So it will slide the magnet. It will slide the magnet left and right to lock and unlock. So that's how it works. Okay, guys, thanks for tuning in. And we catch up again next time. And way to do, I think we catch up again in Discord. If you have anything else you need to ask, don't worry, you can ask me in Discord as well. I will always see you there, right? You have only 3 points. 1 positive, 24 volt for fan. Other neutral for fan. Could I use the same neutral for tap? Okay, this question I ever asked before. The answer is, I don't think you can use the same neutral for tap. Because the fan neutral might affect because the fan is variable, is sometimes high, sometimes low. By using the same neutral for your tap, I don't think it will work. I asked this question before, whether we can use the same ground for 2 different things, fan and something else. So it doesn't work that way. But why not you use the 2 button head pin? Or I think you don't want to use a spring. Maybe you don't want to use spring. That's why. But yeah, if you have 3 points. Not very sure also. You need to think about how you want to install that. But okay, guys. Anyway, let's call it a day here, and we'll tune in again in the next stream, or do find me in Discord. Right. So see you guys. Take care. Have a good evening, good morning, good afternoon, wherever you are, and see you again in the next stream, guys. Thank you so much for tuning in, and see you again. Bye.